Survey. Now, Survey is one of those features and functions that it's going to be hard for me to compare and contrast in a 10 to 15 minute vignette. So you know what? I'm not even going to try. Instead, what I'm going to do is this. We'll talk a little bit about Land Desktop and the survey functionality that exists in the survey module for Land. And then what I'll do is I'm going to transfer you to a recorded presentation where I discussed Civil 3D survey functionality for about 90 minutes, and that will do it much more justice than me trying to ram through a bunch of things in 10 minutes. So, having said that, we'll begin in Land Desktop. First couple of things is if we're going to leverage survey within Land, we've got a survey module that needs to be installed, and we need to access that workspace to be able to reach the pull-down menus that are specific to survey. Now, when we're working with survey, there's analysis and figures. The figures would be the line work that would be collected in the field, or even created within our environment here. The thing to keep in mind is the tools that are available for us with respect to creating the figures and editing the figures are fairly rigid and antiquated, meaning we can't do things like double code. If I'm going to begin a figure, it has to be with a B. If I'm going to map them to a particular layer, I'm pretty limited on that. I can't automatically call it a break line so that building lines would be used as break lines and overhead electric would be not, because I wouldn't want that to participate in my surface. So a lot of that's carried forward over the years. The other thing is it's not very intuitive. If I'm going to work with survey, generally I'm working with a field book. So to get a field book, it's an ASCII file that is translated from a data collector or a field instrument. So there are different tools that are required for that. Unfortunately, most of the newer equipment, be it Trimble or Leica or Topcon, don't support Land Desktop directly. So it requires us to export it to TDS like a raw file and jump through a lot of hoops to be able to be successful. So at the same time, when we work in this environment, it's not a protected environment in that we're in the same general population as everybody else. So when we're attached to a land project, in this case it's Project Survey, the survey points that we construct are part of the same point database that everybody else would be working with as well. And that can create problems in that we're going to have engineers and surveyors and perhaps draftspeople and designers all battling over the same group of points, and you run the risk of somebody stepping on somebody else's data. So in addition, there is a survey tool space that was added to the application in around 2004, 2005, somewhere in that range, and that is the precursor to what we see currently in Civil 3D today. So with that being said, can we be functional? Can we be productive with survey and Land Desktop? Absolutely, and I know many people have, including our office was for a number of years. However, to be successful in it, we need to work with a rigid set of rules with respect to creating figures. We need to have field people who are up to speed with that particular workflow, because it's not very flexible. They either match that or it doesn't work. We also have a fair amount of pain points, and when we bring the data in, we're in a graphical environment, but even though we have to go back and change the data that was collected in the field to get it to update graphically. So in any event, rather than yammering on anymore about what's going on in Land Desktop with survey, let me transfer you over to the presentation and you can see how things work in Civil 3D.
For those people that weren't in my session yesterday, my name is Jerry Bartles. I'm a Civil Technical Specialist with Autodesk. What we're going to be running through today is Civil 3D 2010. We'll be looking at it with respect to survey functionality. There was a lot of improvements made on the survey side as it relates to 2010. So if you're somebody who's using 2009, and we did a lot of field to finish presentations last year using 2009, we got a lot of feedback. You guys need to be able to double code. You need to have more flexibility in this. A lot of that's been integrated into the 2010 version of the software. So we'll be walking through a lot of that today, but unlike yesterday where a lot of what I was talking about was going to be applicable to 9, the majority of what we'll be talking about today will be applicable to 10. Some of it will be applicable to 9, and I'll make a distinction both ways as we go through, but it'll be predominantly 10 we'll be using today. All right. Before I get started, just a show of hands, how many people are currently using Civil 3D right now for surveys? Okay, fantastic. 9 for the most part, or 10? 9? Okay. Fantastic. What we'll do is we'll walk through, take a look at what we're going to be up against here today. Like yesterday, I've got a fairly rigorous agenda. I've got a number of things we're going to go through. We'll take a look at the survey database itself, talk a little bit about how it manages the data. We'll get into the one topic that was mentioned before class about the coordinates and that. We'll take a quick look at that. Field to finish, there's been a significant amount of improvements. We'll discuss how that works and what can be done in 2010. Then I want to show a little bit about integrating GIS data, because once we generate survey data, engineers are going to need it for some respects doing design moving forward, but then there may be also geospatial people that you collected a bunch of trees. How can I share that with them? You know, how do we transform data from one projection to another? We'll take a look at that. There is a concept within Civil 3D, I don't know if you're using it now, but the fact that you're in Civil 3D, but we can extend the survey point database or the point definitions themselves. Traditionally, a point has only had a point number, northern, easting, elevation, and a description. And we have the ability in Civil 3D that we can extend that to include additional columns of data quite easily. So I'll show an example where we can use it for trees, but it's also a mechanism we can use for, we go out and we shoot rims on structures, and then have somebody go back later and then measure down inverts. We can add those inverts back to the database, have it automatically subtracted from the rims so that we're not calculating, you know, inverts. And if my data updates, my inverts and that will update as well. All right, so we'll take a look at an example of that. And then finally, if it's not noon at that point, we'll take a look at how we can utilize or leverage some of these survey lines in our design process. So, and I promise I won't PowerPoint you to death. Just want to lay down a little bit of a foundation how we're different than our legacy application in Land Desktop, and how we manage data in the Civil 3D world. When we deal with points, the survey information is maintained separate from, say, the engineering information. They will have the ability to create points for you know, tops, foundations, and things like that on the design side. We will have the ability to go out and collect data that has observations and prism heights and things like that. But our data can remain separate from theirs, so that you can serve up the information you'd like them to have and leverage in their design, but you don't have to worry about some moron coming in and deleting all your control or rotating your stuff and doing something that they shouldn't, okay? So your stuff remains separate in this database environment. Because of that, you know, it's the environment we can use to, you know, serve up or leverage geospatial data, engineering data, surveying data, and it's all under your control. How it works, there is a survey database that will be stored on your local machine or on a network drive, whatever's most applicable for your situation. That survey database is going to maintain 4 things now, and that's one option or one thing that's different than 2009. What it's going to maintain is it's going to maintain an import event. So if we go out and we collect data in the field and we bring that information in the past we would just dump it into the database, and we would have the points that were shot, maybe the line work that was generated, observations, but somebody would want to go back, when was that collected, who collected it, when was it downloaded, information like that. That's now all stored in what's called an import event. All right, so we have some ability to go back and track that. We can reprocess it. If additive factors need to be added to our points, we can track what the original number was compared to what it is now, so there's a lot of flexibility involved in that. In addition, we've got 3 other values. The network itself is kind of like what we actually did. We set up over a point if it's a total station, what our instrument height was, what we backsighted, all of our observations, prism information. All of that is maintained such that if we make changes, because it's dynamic, we update a prism height, and anything that would update as a result of that would automatically propagate through the rest of the model. So we'd have networks, and then as a result of our collection, figures would represent our lines, and then survey points would represent the actual shots themselves. All right. All of that's maintained in a database for our use. We have a couple other databases that are available as well. There is the equipment database. What that does for us is it will maintain specific information about our equipment. So if I have 4 identical Trimble units, each one may have slightly different calibration information or standard deviation, prism constants, different things that even though they're all identical equipment, they all have slightly different aspects. And if we're going to create a least squares adjustment and we want the highest level accuracy possible, some of those factors may need to be adjusted into the equation. So what we can do is, rather than having to write these down or remember what it is, we can save specific information about each piece of equipment and create like a virtual instrument. Here's instrument A, instrument B, instrument C. When we process the data, we can say it was collected with this instrument, and we'll apply those values and we can go from there. The last one is the figure prefix database. If we collect line work in the field, what that does is it maps for us layers, line types, pen weights for the lines that are collected. So if I'm going to go out and spend the time collecting points that are going to represent curbs and driveways and fence lines and things like that, when it comes into the system, it would be nice if it automatically went where it was supposed to with respect to layer and color. At the same time, some of these things should automatically be used as break lines. So when I calculate a surface, I don't want to have to retrace these things to use them as break lines, or maybe some things should be break lines, other ones shouldn't, like an overhead electric line. I want to see line work, but I don't want it to represent my contours or anything like that. All right, so that'll be done through this guy. As I say that, is everybody collecting line work in the field right now for the most part? Okay, good. It's good to see that number going up. It's some of that technology's been around for a long time, and when we started doing the field to finish presentations last year, it was interesting to see that so small of number of firms were actually leveraging that, and there's a huge time savings that can be incorporated into your projects by doing it that way. So, with respect to the database itself, how are we going to get data in and out of it? There's a couple of different ways. First way is our hardware can support it directly. For the most part, at least in the DOT side, there's a large Trimble presence in Wisconsin. Trimble creates an application that's called Trimble Link. Trimble Link will run directly within Civil 3D. It will allow me to connect my instrument, my survey controller, directly to Civil 3D, transfer data back and forth. All right, so I don't need to convert to an intermediate file. It'll take my job file directly out of the collector, migrate it directly into the database, and I'm ready to go. If I have something, other hardware vendors have similar applications. If I have an older instrument or something that does not have a hardware provider that will integrate directly within Civil 3D, then we can start working with different file formats to translate the data into the survey database. One thing that is new to 2010, in the past, if we brought the data in and we wanted line work, it had to be a field book file. All right, now in 2010, that restriction has been lifted. It's flexible enough that we can generate line work straight from an ASCII file. I mean, we can generate line work straight from points off the screen. We can window the points and say read the codes, generate the line work, and it'll go from there. So that significantly increases our flexibility in the field, in that when I collect data now, it's the description that's the most important thing. I don't need special notes or anything like that added to the collection that will make my line work. I just have to add a description on the point and I'm done. Finally, if we have any old school, hardcore, I want to do it all off manual notes, there is still a survey command line language that we can enter. I'm set up on point number 5. My instrument height is 5.2. I'm backsighting point number 8. I can enter it all manually and it will add data to the database. So, yes, sir. LandXML will bring in line work. The thing we need to remember on LandXML, there's actually 2 flavors of LandXML. There's the one that everybody deals with, and then there's what's called Survey LandXML. The reason I say that is Trimble will export a LandXML file. If we just bring that in or leverage that, the lines that we shoot in the field, it will think they're roadway center lines. They'll think they're alignments, because that's typically what a LandXML sees. So there's a different flavor of that called survey, like survey grade LandXML, that will understand that the difference between a center line and a curve. Basically, when the line work comes in, we want it to be a survey figure and not converted into roadway alignments or something like that. But yes, I don't have a good example of that, but we can talk about that later. So, finally, the database itself, a coordinate system can be applied to that. What's beautiful about that is I can now transform things on the fly. So by connecting a drawing to this database, a simple drag and drop operation, if this is an estate plane projection, and I have to integrate with data that's at a county or something that's metric or some system that I'm not currently in, I can connect the drawing to my database, drag it into the drawing, and transform it on the fly. I don't have to recompute any of my data. It will immediately go from safe plane to metric. And if they have data in their file, I can grab that, drag it into my database, and it will transform it the other way as well. Okay, and we'll take a look at a quick example of that. So, and then ultimately, this is how it looks in the task pane. If we're in Civil 3D, the data will come from the collector, populate the survey database that sits in the survey tab within the system, and then depending on what the coordinate system of drawing is, we can move data back and forth. All right. As far as line work or field to finish, let me explain this a little bit. If you've done line work on the Civil 3D side or prior to that Land Desktop and prior to that Softdesk and DCA, our methodology for collecting lines has really stayed the same. We'd say B for begin, give it a figure name, and it would start drawing line work. But then there was people who would come back and say, well, we're used to coding it differently. I want to say back of curve, start. Or I want to use an exclamation point to tell it pen up and pen down. Well, ours was hard coded. You had to follow that strategy or that was it. And that was very hard from a field perspective. Change is difficult. We've got guys collecting stuff for 20 years and you tell them I want you to do it different and they tend to resist that a little bit. All right. So in this case, what we did is on the 2010 side, instead of coming up with a methodology that matched what somebody else did, because there were some people, well, I want to code like Eagle Point does. I want to code like Carlson did. I want to code like, Brand X, whatever. Instead of making a utility that would convert all of those, we have kind of the Uber tool now. And what the Uber tool does, you get to go through and you specify all the different ways we would collect, from using special codes for line work, for starting, ending, for doing line work, for doing curves. I can program exactly what I want it to be. So if you want to start your line work with an exclamation point, or you want to start it with B for begin, or you want to start it with an S for start, whatever makes sense to you, you can just code it into the dialog and it will leverage that. If you want to pick up your data so that it's, begin figure, or you want to pick it up such that it's figure begin, it will understand either direction as well. Okay, so we should be able to match, if not exactly, very, very close to what anybody's collecting with right now. Okay? So that was one of the things that was came back to us time and time again as we went through with these presentations, that there needed to be more flexibility, and now we have a significant amount of flexibility incorporated into this. So we've got the special codes for begin, continue, end, closing a figure. We can do horizontal and vertical offsets. Yes, sir? They can be numeric. Yeah, the question was, do they have to be alphabetic in that, B or X or anything like that? They can absolutely be numeric. Yep. We can do horizontal and vertical offsets. We'll take a look at an example of that. What I mean by that is we're going to pick up a curb. We can pick up the back of curb, and we can tell it at the same time I pick up the back of curb, I'd like it to offset half a foot to the face. I'd then like to offset a little bit further and drop down to pick up the gutter. I'd also like to offset a little bit further, maybe come up for the edge of pavement or the flag of the curb. And every shot I take after that, it will automatically collect 3 or 4 lines or whatever I put in, so that I don't have to keep picking up multiple points if it's a consistent object. All right, at the same time, you pick up one side of the sidewalk, you can say 4 foot to my left, and it'll pick up the other side of the sidewalk as well and just maintain the elevation unless you tell it what the difference is. Line work, there's a lot of codes for that. We'll do those on the screen. Even as much as I've got one down here at the end, extend. What was interesting about this is when they built this tool, they looked at how all of the other packages were collecting data. What options do we give people? What options do our vendors give people? Everything that's out there. And it was kind of interesting to say they tried to incorporate everything that everybody allowed people to do. Some of the cool ones on line work is extend. So if I'm going to take a shot at the end of a curve or something that's here, and there's a tree that's blocking my line of sight, I can actually go past that if I'm connecting a line. I can take a shot here and then put in a negative value to automatically shorten up to where the shot actually is, or I can give it a positive value to continue to extend the line until where the end actually would be. All right, so lots of stuff that we couldn't even, it would be very difficult for us to accomplish before. Finally, we have curve segments, multi-point curves, one-point curves. We'll take a look at those as well. So, just very quickly, if I was going to collect line work, one example and how we'll be looking at it today, I've got a TBC1 for like top, back, and curb. I've got a 1 on the end of it to make it unique. I'm going to tell it B for begin. I take the shot, step out into the center of the road. We would say CL for center line, or however we were going to code that, B for begin, or whatever code we wanted to use. Step over to the other side to pick that one up. As we march up the street and take the next shot, we give it the same code as what that side of the street was, in this case TBC2. The system will automatically connect up a figure line and give it that name. You step into the middle of the street, that figure will be extended, as will the one on the other side. There is no limit to the number of lines that we can have being collected at any one time. So if you have right away, bottom of slope, edge of pavement, center line, edge of pavement, bottom of slope, you can have 20 going across, 20 coming back. You can have as many lines running as you need to. We can continue on. In this case, if we wanted it to end, we would say that's the last shot on the back of curb 1. We'd say E, step out in the middle of the street, end the center line, step over to the other side, end that one, and all 3 figures would have been created for us automatically. Within our survey tool space, there is an inventory that's automatically maintained. We can go back and then quickly see a listing of all the line work that was collected. We can put them in groups. What might be lot lines, what might be asphalt, what might be pavement or center lines. Okay? Curves. If we were going to do a quick example on curves, my edge of pavement, we can go ahead and say edge of pavement 1, BC for begin curve. Now, if we've used our older coding before on land desktop, we could never start a curve on the first shot. In the past, we always had to capture a line segment and then start the curve. Here we just tell it BC, begin curve, and it starts going. No extra segments. Take the next shot, edge of pavement 1. So the curve was turned on. We continue to take shots, edge of pavement 1. The next one we say end curve, and it automatically fits a curve through those points. Okay, so I don't have to like multi-point curve, start, end. I just tell where we want it to begin, take all the shots we need, where we want it to end. I can be doing this in a serpentine fashion back and forth across the street, so I don't have to complete one curve before I go into the next one. Makes life a lot easier. Question? Yes, sir. The question on that is the figure that's created 2D or 3D. The actual object that's created is a survey figure line, and it's kind of a glorified 3D polyline. All right, and I say glorified 3D polyline in that it maintains elevation, and it will actually, like on the curves, it will warp, the curve down and around. But we can select that line, and we can ask the system, I want to see grades, and it will show me grades for every point all the way along that. So if we're going to do QA, QC, my guys go out and collect a whole bunch of stuff. I can grab the edge of pavement and I can review all of the slopes along that entire segment. 1.5%, 2%, 1.5%, 16%, what happened there. Then I can start to look and see the elevation when we shot, did they change the prism height, but it'll maintain all of that for us. Okay? At the same time, if I'm worried about taking shots and I want to get a true horizontal distance between lines, and now these things are sitting in space how they were actually shot, within Civil 3D we can apply a style to the line work to say, we know it's got 3-dimensional qualities, but I want to display it only as a 2D object. So now as we take measurements, curves are all horizontal distances. So it's a matter of what style we apply to it is what we'll get. Okay? Yes, sir. Yep.
What happens if you're surveying and you decide to go back and pick it up? Will it have to buy it?
Yeah, the question is like, we finish, I get down here and then realize, I probably should pick up another one in the middle of here. What's going to happen is a couple different things. We have more flexibility than we had before, in that I don't have to go back and change it in the field book. I can change it in drawing, and it will update the line work in that accordingly. When the information is processed, we can do it by point order, or we can do it by import order, but there will be some things that we'll manually have to fix, and that will probably be wrong. It will depend on the situation, but some things we can resolve automatically. In that particular situation, we have to resolve manually. Okay, but we don't have to go back into the field book and do it anymore. Yes, sir.
So if you had a screen to set the roadway before that, you just you start your line, and then once you get to the beginning of the curve, you just
BC. Yep.
and then EC, and you can keep going straight.
And just keep going straight. Absolutely. Yeah, and I'll do that. I've got an example. I just want to lay down some foundation here, and then we'll do some of the drawing. Okay? All right. Top of curve, beginning. Oh, in this case, we can do one-point curves. All right, one-point curves are fabulous. All right, let me finish working this out. We're going to begin. We took the second shot here. I've got a next shot. I'm coding it as OC. It tells the system that is a point on a curve. All right, so it's my one-point curve. We'll take the next shot. I'm back down here. When it will complete the rest of my line, and when it finishes, it automatically generates a curve based on that shot. So it determines what the radius is with a single point. All right. Now the beauty of that is it computes for you where the exact PC and PT are. If ever you've had guys in the field walking around a curve return or islands or something like that, you know, you'll have an expansion joint or something you can take a shot on, but you know, if they don't hit the exact PC or PT exactly, when the line work's drawn up, you have kinks. The arc comes around and there's a kink that goes to the line, and then usually the engineers start crying about that. They want that straightened out and looking a lot better. Well, here what we can do is we can take the line, the shots that we take it a little bit before the PC and a little bit after the PT. You just take one shot on the curve, and it'll automatically compute where those are and give us a nice smooth computed arc through those. All right, so essentially if we look at it that way, everything we shoot is a line, unless we say OC, then it's on a curve. We only need one because it will look at the lines in and out to determine what that is. Okay?
What if in that situation you could measure to the PC and the PT, you take the 1 point curve, and is there always a solution? Or if it doesn't actually have a solution, if the radius isn't perfect, there's a reduction in radius.
Okay.
Air, not process that line?
Yeah, the question is if I shoot something that has to compute, is there a chance that there may not be a solution based on the data that was collected? Like, you know, I'm too far apart this way and I picked it like a 90 or, you know. I don't know if it'll throw an error. My guess is if it can't do it, the code will be ignored. So you would have like a hard edge, and then we'd have to resolve that in the system, but it's not going to come up and flag you that I'm aware of. Okay. Last one, horizontal and vertical offsets. What this is going to do for us, like I said, we'll take our shots. If we've got a curve that's a consistent, you know, lift and then drop and then out to the front, rather than taking multiple points to get the flow line, pick up all the data that we need about the curve, we're going to take a shot and we're going to take and include some horizontal and vertical offset information. We only need to do it once. Every shot we take after that will incorporate those. So we'll work our way across. I'll get down here to the end and then we'll see what they are. So as I take my shots, the first shot was my first shot is the code, would be top back of curve 1, begin. I'll just put in a horizontal of 0.5. I've got vertical of 0, just I guess to make it clearer. If it doesn't change vertical, you don't need to say anything. It'll use the same elevation. So I can say horizontal offset 0.5, vertical 0. We'll step over to the next one, which is now here. Now my horizontal offset is 0.67, and I'm dropping down negative 0.5. Then I'm going to step out to the end, horizontal 2 foot over with a negative 4.7 to give it my slope of my gutter. All right, so I apply those values. That's in my first string when we collect the first shot. Every shot that we take after that with TBC1, it's automatically going to continue to extend those figures. If you throw the code in to create a curve, like we talked about before, it's going to continue to pass those codes around the curve as well. All right, so very, very easy to use. If somebody, let's say they do the codes in the field and they don't measure down what those values are, they mess them up, that one code we can take and change in the office as far as what it's supposed to be for that standard curve, all of the line work will update automatically. Yes, sir? Yeah, if we come to a driveway, there's a couple things that we can do. There's a code that we can put in that says SO for stop offsets. We can double code now. We can triple code. I'll show you an example of that. You can quintuple code. You can do anything you want with that. So we can still have it hit the driveway. We can go up the driveway, come back down, and have it resume on the other side. But in the event of the curb where it's not going to be a mountable curb and it's going to be ground out, what we can do is we can put in a code to tell it to stop the offsets. We can do the driveway and then start the offsets back up on the other side or a different level of offsets and they'll pass through. Okay? Yes, sir. Absolutely. Yeah, the question is, can I start at the flow line and have it go left and right? The offsets, as we put them in, if they're positive, they'll go to my right in the direction that I'm walking, and negative, they're going the other way. So just add the values and we can go to either side. Yep. Question?
So what was that actually? You took 4 different shots. That first one was you just built on.
No, what I did is I took just a single shot here at the back of the curve, and then I just coded in the values of what this point would be, this one, and this one, so I don't have to shoot them. And then I'll just take and run it through. And like I said, sometimes people get hung up, oh, my guy gets out in the field, how's he going to know exactly what that is? Or if he puts something in that's close and we determine it later, we can change those values and all the line work will update automatically. So we've got a lot of flexibility with that. That's the beauty of us working with a model like this is it's dynamic, so we make changes and propagate through the rest of the model, and we're good to go. Okay. So let me hop out of here and do a little bit of this. Excuse me. I'm into Civil 3D. Couple things. The tool space that I'm working with on the side, for the most part, will have a prospector and a settings tab. There are actually 3 more tabs that can be displayed on the screen. One is the toolbox for reporting. That may or may not be on depending on what we run. The other one is the survey tab. There's a button up here at the top in the ribbons that I can select for my tool space that I can turn that tab on and off if it's not there now. If you're a typist, like I am, you can type in, now I'm going to say that and not know what it is. It's OST for Open Survey Tool Space and CST to close it if you want to hard code it yourself. But we'll bring up the tab for survey. I'm going to open a drawing here. Let's simulate a little data collection. This is actually a park not too far away from my house. If I'm going to collect some information for, say, the edges of pavement here and maybe the center line, just to see how this is going to work. Once again, the beauty of this is it's all done off the description. So even though I'm not using data collection equipment, we're not out in the field. If I can do it with points on the description, that means all I need is an ASCII file collected in the field, and this will work fine. Let's do this. We'll create some points. So we'll say create. I'm going to create a manual point here. I'm going to pick a point near what would be, we'll say, the edge of pavement. And point description, I'm going to say EP for edge of pavement, and we'll say B for begin. So my guys take that shot. We'll hit enter. That immediately goes to the back, so I'm going to change my draw order here just very quickly so we can see it. So there's the point that was collected. We'll take my next, that's not too bad. Let's take a point out in the middle. So my shot in the center of the street, this is going to be CL for center line, B for begin. And then maybe I'll begin this one just at the edge here for right now. We'll look at curves in a moment. So this will be EP perhaps 1. They need to be unique so it knows which side of the street I'm on as I'm collecting. So we'll say EP1, begin. After that, as we continue to march down the street, EP1, we'll take the shot at the center line, take a shot at the other side, EP, and then we'll do one more to wrap it up. So EP, center line, and then my final shot here at the EP1. Now, if I don't want to reuse the same figure name or figure code like EP or EP1, I don't even need to tell it to end. When I stop taking shots, it knows I'm done. All right, if I want to end it at a particular location and then start it again someplace else, then I physically have to say E for end. In this case, that's why I didn't do it, because that's all I'm going to take on it. All right. That being said, I've got some data now that I'd like to work with. We're going to process. What we have is using the ribbons within Civil 3D. We're going to use the Home or Create tab. I'd like to import survey data. All right, this is one of the things, if we were working in 9, one of the difficult things was the process involved with, okay, I got to create a database, I got to create a network, I got to import a field book. Here there's a wizard now that walks you completely through the process. So we're going to say import survey data. It's going to ask us, okay, which database do you want to put the data in? I've got a couple that are listed here, or we can create a new one. So we'll say WGUG. The database is created. Rather than using the defaults, I'm going to edit those settings. And the thing I'd like to set here is, this is currently for a coordinate system, is Illinois State Plane. So we'll come down USA, Illinois, East Zone, US feet. I can continue to go down and establish other values as well. Now, one thing I will point out was one that was mentioned earlier. Civil 3D, unlike our former application, if you were using land, has the ability to apply sea level and atmospheric corrections and various things to the data within our database. Land Desktop was not able to do that. All right, so if we had data that came out of a Trimble data collector, they applied correction values to it. We would see those values on the screen. You dump them in the Land Desktop, the values matched. They had to match because Land couldn't do anything else with it. On the Civil 3D side, if I bring the data in from a Trimble device, for example, they strip all the corrections off. Because if they didn't, and I said to apply corrections here, there's the potential that they would be double corrected. All right? So they strip the data off. I dump it into Civil 3D. If I don't apply the corrections, my numbers are now different than what was in the Trimble. And it's like, what's going on? I've been dumping this in the Land forever. Everything's fabulous. I dump it into Civil 3D, and my numbers don't match what's in the collector. All right? So I'll need to look at what values I'd like to use. I will check those on, but because by default those are turned off. All right, there's one other thing, and that was what the individual mentioned here before we get started, or before we started this morning. Generally, it is the sea level correction that we'll want to make sure is checked on. The way that we were applying the correction was slightly different calculation than what Trimble did. Ours was based off of solely the instrument height. Theirs was based off of the average elevation between the instrument height and the elevation of what was being shot. So there was like a different value applied to every point based on the distance. So some people noticed that when they brought their data in and applied the correction, the values were still a couple hundredths different than what was in the collector. That should have been resolved in the Survey Pack 2 for Civil 3D 2009, and it absolutely should be there in 10. So I throw that out. If anybody experiences that or sees that, hey, my numbers don't match, they should exactly match, and if they don't, please, let us know. That's something that's very important to us to make sure that this is going to give you the highest level accuracy possible. All right, so I point that out because that is one common thing that people deal with. All right, I'm going to come up for right now. We'll just worry about the projection. We'll say next. Here's where we can bring the data in. If it is a legacy fieldbook format like what we've used prior to 2010, we would select that. Land XML if it was the survey flavor. A point or an ASCII file, we could just process that directly, or now we could generate line work right from the drawing. So in this case, I'll say, you know what, let's generate line work from the drawing. We'll select the points. We'll do S for selection, and we'll just grab these objects. Right-click. I'm going to create a network, all right, or an event in the field, if you will, for what day or so that we collected this. We'll say this is day 1. So I can have all of the day, all of the information computed, if you will. I'll have some indication of what day or what time it was collected. We'll say next. When it processes the information now, which figure prefix database do we want to use? How should it map the line work, in a sense? How should we name the import event? Do we want to process the line work by point number or import order? That gets into if there was changes. Do you want to do it solely by the points in ascending order, or do you want to do it by how they were imported? We can control some of that. Point number is fine. We will say finish. It processes it, and you can see that I didn't click very well with my shots, but we can see the line work. Those lines don't show up that great, so let me make a quick change here. I'm going to change my layer. Actually, we'll do it through this guy. What's displaying that on the screen is a style. It's a curb style. It's being used as default, so we're going to come down to V-Road curb. We'll set that to something that's going to be a little easier to see, and then we'll apply a width to it. at 0.3. All right. So as we picked, it automatically processed, it generated my line work. Now as we come into the database on the side here with our points in that, here is the import event. If we look at the import event, it's got a name. We just processed it from the drawing. We can see what networks were created. We can see what figures or line work was created as a result of that import, as well as what points. All right, everything is dynamic. So if we're out in the middle of space, we come down to a particular figure. I'd like to see edge of pavement 1. We can right-click and say zoom to, and it will take us immediately to where that is. If we're looking for a particular point, and it's not that exciting when I have 10 points in here, but if I had 20,000 points, we could say zoom to, and it would immediately center that for us on the screen. So we can interrogate the model to find information out about what we've collected. Everything right now is elevation 100, so it's flat, so I'm just using it for line work for right now. Let's do this. We want to take and dial it up a little bit. Let's shoot some things on the side here. If we'll come down and do some stuff at the corner. We'll add some more data here. Points. Manual will drop a point here. This will be, we'll say road B for begin. We'll take another shot. Road is my continuing shot, so it continues to connect up a line. If I want offsets, because I want to start picking up the curb, maybe I hit a point where there's curb now. I'm going to select a point for my curb. We'll say road. H for horizontal offset, we'll say 0.5. That's going to get me from the back of curb to the face of the curb. I don't need to give it a vertical because I'm going to maintain the same elevation. Then I'm going to say maybe H of 0.55. I'll come out 0.55 feet and we'll drop down to get the gutter. Maybe the gutter is going to be a vertical negative 0.45. And we'll just make it easy, negative 0.5. Space will come out to the flag or edge of pavement. That's going to be maybe a horizontal. It'll be 1.5 foot curb and gutter. We'll say horizontal 1.5. Vertical maybe negative 0.43, so that I come up from the gutter a little bit to the edge of pavement. And that's all I need. That code's been added. We'll add another code here. It'll be road. So it's going to continue that on. Now I stop short of the PC. I'd like it to automatically calculate the curve for me. So I'm going to pick a point here. We'll say road OC for on curve. Come around the horn. I'm going to go past the PT. So it'll compute it on its own. Road. We'll take our final shot up at the top here. Road. And we can continue on. Let's do one more just to show you this. It's going to be doing offsets all the way up. If I want the offsets to stop at a particular point, we can say road SO to stop offsets. I'll do one more shot and we'll see it'll just be a straight line then from there on out. That's how we would stop, and then we could create new ones from there. All right, let's process this and see what we're up against. Import survey data, same database, points from drawing. I'm going to create a new import event. Generally, I wouldn't be doing a bunch of them in the same drawing, so that's why it flagged me. We'll say selection. I'm going to grab these guys. Different network. Maybe this would be day 2. We'll say next. Process the line work. That's fine. It gives us the ability to add offsets. I could literally select. In this case, I'm not doing text files, but I could select 10 text files. If I have 5 crews or 6 crews go out and pick up, a number of ASCII files for data, I can dump them in all at one time. If it's like the survey crew that I used to work with, every day was a brand new day, so they go out to the same job every day and start collecting at point number 1,000 again. All right? Can be a problem. So what happens is I can add an offset so that when this guy starts at 1,000, add an offset so they remain unique, but maintain that number that they originally shot. It will maintain that in the import event. All right, the beauty of that is when they come back to me in 3 days and say, that stuff we shot on Wednesday, 1100 to 1120, we got to change the elevation. And I'm like, I have no clue what those numbers are anymore because it's all been renumbered. The import event will keep track of that for us.
Let's just say you had
Yeah, the question is we go out and we shoot stuff for 3 days, but maybe I want somebody to start looking at it as they're collecting more data. As I bring the data in, there will be options to say, delete and overwrite what's already there. So if it didn't change, just, overwrite what I already have because it's no different. So we'll go ahead and finish that. It generates my line work. And if we come up and look, you see my line hit the point where I had the offsets. Works its way around the corner because I've got 1 point on a curve. All right, very nice transition moving through there. No engineer or anybody's going to complain about that. I'm going to come up here to the top. We hit the SOs for the offsets, and then we go right back to an individual line, and it's going to carry on from there. All right, so I'm not worried about hitting PC, PT. I just got to make sure I'm a little bit further out. It will take care of itself. Now, what if the individual made a mistake? They coded in the offsets wrong. Let's say, worst case scenario, the curb was supposed to have offset to the other side, and now I've got all these offsets to the right. All right, let me do this. I'm going to, this is a special situation because I threw points in here and I processed them and generated line work. So I've got points in here that are actually civil points. All right, I don't want the civil points in here. I want to use the survey points, so I'm going to delete these, bring the survey ones in. But I want to show you the difference. The fact that it's a civil point, which is what I started with, I have a grip here on this shot. So because I have a grip, I can start moving that around. All right, and the survey people just start cringing when they see CAD people doing stuff like this. All right, what could possibly be wrong with that? All right, so I don't want to use the civil points, or I don't want to use what I started with. Instead, I'm going to do this. We're going to erase that. So we'll erase these guys. Okay, so those guys I've erased out of the drawing, but they still exist in my database. So we come down to my figures. Here was my road information. You see the offsets that were created as a result of that are automatically tagged .1, .2, .3 based on the offsets. If I click and hold on this, I can, well, first if I highlight it on the screen, you see it light up here. So before I even commit to needing it, I can see where it's at. I'll highlight this, we'll drag it into the drawing, let go. It generates the line work. Let's grab the survey points for that as well. So we're going to come down. We'll just grab these ones off the end. We're road. So we'll take from 14 to the end here. I'm going to drag those into the drawing as well. Now, those, if you noticed, I dragged out of the database. Because those came out of the database, that's like me serving data up to the engineer now. I've given them data in a drawing, but it's still tied to the database. It's mine to control. All right? So what that means is if I come down here and look at this same point, if I pick on it, you notice there's no grip here. All right? It's like when Dad set the thermostat at home. It was set that way for a reason, so nobody's supposed to be touching that. Okay? So, now I can erase it off the screen, and it's fine because it's still in my database. They can change the way that it looks, but they're not going to modify the data. All right? Now, because it's a survey point, if I wanted to make changes to that offset, I can highlight this, and using the contextual menus in Civil 3D, the ribbons, I can highlight it, and without having to dig in and find where that command is, here's my survey point properties. I'm going to take a quick look at that. We're going to come down. Here's where it was coded. Oh, well, this is where they made the mistake. It should have been a negative 0.5 offset for the other side, and then this one would have been negative, and then this would have been negative as well. The verticals were fine, they just offset them to the right. They should have been offset to the left. All right? Our last version of the software, you would have been back tweaking the original field data out there and then reprocessing it again. Here I can change it within the file. We'll say OK. When I hit enter, it says, hey, you modified the description of some of the survey points. Do you want to update the line work? Absolutely, I want to update the line work. Reprocess with any changes to figures or layers or anything. I don't. We'll right-click. It's bringing my points back in. We'll go ahead and overwrite that. And if we look now, my line work now offsets to the other side. All right, still honors the point on curve. All right, still get a nice smooth transition from one side to the other. But just by tweaking it now, I can deal with it in here rather than having to go back to, all right, where did they take the shot, change that, reprocess it, run it again. Okay? Let me do one more quick thing here. We'll double coding. All right, that was something we used to get hammered on all the time. We go do the presentation and, they were like plants. They raise their hand. Can I double code? Because, a back of curb's going to hit a sidewalk. I want to take one shot. All right? Now, I was the CAD guy in the office, and I had been out with some of the field guys. I didn't have a lot of sympathy for them because when I was out with them, they'd be like, well, okay, the back of curb hits the sidewalk, and, well, hell, there's a hydrant right there. I'll just add an offset for that, and there's a valve right there. And their utopian situation would have been to take one shot with 1,000 offsets. All right? So when they started complaining about double coding, that didn't resonate much with me, but resonates with a lot of field people, so it's been incorporated now. We didn't limit it to 2 codes. Can we double code? Can we triple code? It's as many codes as you want. All right? You can go nuts. So if I want to do something like that, I'm going to come in here, because then I had people, I want to start a shot with 4 lines, and then I want to break them apart because pavement striping or something. And then I want it to end, so I want to start with 4, have them break apart, and then converge back. All right? Crazy stuff. So we're going to go ahead and create some points here. We'll do 2 things. We'll say manual. I'm just going to come out here on the tennis court. We'll pick a point. Description. Let's say there's stripes. I'll say ST for stripe. We'll say ST1 begin, space ST2 begin, space ST3 begin, ST4 begin. All right, so you get the idea. I could keep going all day long. I could write a story. So we'll do that. Location for the next point. These may break apart. It's going to come out to here for my stripe. Well, that's going to be ST1. This guy's going to come out here to ST2, ST3, ST4. And then finally, we'll take a shot back at the end where they all converge. ST1, ST2, ST3, ST4. All right? Absolutely not rocket science. Doesn't matter what collection equipment I'm using, if I'm using Topcon, Trimble, whatever. When I shoot the point, I apply the code. It'll do my line work for me. All right? No special notes, no fancy recall statements or anything like that. All right? That looks good. I'm going to do one more thing before we process this. Let's take a look at a quick example of where I pick up a driveway, perhaps. All right, how this is going to work. It's the weirdest thing when you work on stuff where you know people where they live. We'll do it at Jim's house over here. I'm going to take a shot on this side so we can pick up his driveway here. We'll say points, manual. I'm going to take a point right here, and let's say this is going to be RD for road. I'm getting lazy now. Say RD begin. So, and you know what? Let's do this. I'm going to throw some offsets in here too. RD, maybe a horizontal offset. I'm going to go to the left now. So negative 0.5. And I'm not going to worry about verticals. We'll just make it easy for right now, negative 1. So I'll just have a couple lines being offset to my left. Which way I'm going, yeah. So as the direction I'm walking, positive will always be to my right, negative would be left, and as we saw, if they mess that up or whatever, we can fix it pretty easy. All right, get to the driveway, just like we saw with the stripes. Well, at this point right here, that's an RD shot, and then, oh, by the way, that's going to be DW for driveway, or whatever my code is, space B for begin. Okay, now I'm going to send my guy up the driveway. He's going to take a shot here, driveway, walk up around the house, have his German Shepherd barking at him, walk up on the other side, we'll come across, very quickly starts to seem like work. All right, come back down the other side, we'll get the little return there, we come out to this side, DW, I could say end if I wanted to, we could say DWE, I'm not going to have any more driveway shots, we'll say RD for road, and it's automatically going to continue on with what I had before. We could come up to the next one, RD, and do driveway and walk up and around the next one. We'll just do one shot here. We'll call that good. So, like I said, very intuitive. I mean, if we weren't coding like that before, it's pretty straightforward. Even if we get the shots, we can add the codes inside the office if we need to. Let's do this. One last one we'll process. I'm going to say import survey data. Next, point from drawing. We'll create one more import event, selection. We will cool command in AutoCAD if you haven't seen it before, WP, all right? Window, you get a window. C, you get crossing, picks up everything within the window when it touches. If you say WP, you get window polygon, so that means I can be like a surgeon here, and I can pick out exactly what I'm looking for. So I want to pick up just that stuff. Okay? If I would have grabbed it with a window, I might have grabbed something I didn't need. Some real cool ones if you haven't seen it before. WP is window polygon, CP crossing polygon, same as a window, but it picks up everything that falls inside, everything it crosses. F for fence, you just pick points, generates a line, anything the line touches it picks up, so if you got a row of trees or something like that, great way to grab the data. And then the scary thing is that's been in the software since like release 12. All right? So if you haven't used it, it's new to you. All right? So we'll go ahead and grab those. Those guys are good. Day 3. We do a very good job of talking about what's been added to the software, but the stuff that's been there forever, it's like, everybody knows that. So say next. Process those. Wrap that up. Okay. Started at one point, everybody broke apart, ended at one point. All right. Looking at that, you can pretty much do anything. You come up here and you see that leverage for the driveway. We see the offsets running across the driveway, and at the same time, those guys hit exactly with the driveway points. So nobody having to go back later and extend it or worrying about things crossing over each other or, saying it doesn't look right, trying to fix it.
Just a question, like add that driveway point, remove the offset, vertically, can you adjust that offset and remove it?
At that one particular point, yeah, if you're going to use the same offset, it's going to process that all the way through. So if I was going to change it, I'd have to set a new set of offsets for those.
When you enter in a new offset, it'll pick out.
It'll be new offsets for that point. Well, from there to the other side.
Like they were going to shoot together,
Yeah.
goes down and you just pick the next one.
Yeah, or maybe you want to have the one at the top but I don't need the one in the middle. I may have to take 2 shots because I'd have to test it to see if I could have, because I'd be telling it to stop the offsets and then immediately create new ones, and I may have to do that in 2 shots. But worst case is you'd take a shot to stop the first one, start the next ones, and then go. I haven't tried coding it all in one. It may work. Okay?
I didn't know that then you also have an alternate code on that line. So
Mhm.
you can stop, it doesn't matter.
No, what you do is you could stop just a little bit short of that if you had to. Say stop the offsets, then hit the one for the driveway that's just a little beyond that. Give it the new values and then go from there. There's a recall. There's a whole bunch of stuff. Let me show you that as well. The tool is here in the Linework code set. If we look at sample, this is the Uber tool here, if you will. This is where I can go through and specify B for begin, H and V for horizontal vertical offset, PC and PT for begin curve, end curve. I use BC and EC in our example, but that seems like back a curve and stuff for me, so I've coded mine to be PC and PT. Excuse me. Point on curve. You can even do circles. So you can take a shot and say I need a 5-foot radius at this point. So one shot, give it a radius, and it'll create a perfect circle. All right, a lot of different options available. Any of these help. I know that people tend to stay away from a lot of that, but if we go into the help on this guy, I'll get some options here that says examples for Linework coding. So if I hit that, all the different things that we would collect, say for example curve segments, it comes through and gives you examples of how we would shoot, like for a pool, a circle, 5-foot radius, all of these things, how you could, all the different things that you would run up against, how you can leverage all of those codes. All right, Linework, if you're picking up stuff on a house, all right, I can't always see all the interior points, around the building. Maybe I'll see just some of the outside. Well, there's codes that I can take a shot and then maybe take the next shot to establish the line, and then I can say I want to go right so many feet, and then they're right. They don't have right and left. It's right and positive, it goes to the right, or right negative, and it goes to the left. But we can add values and march our way all the way around the building in that as well. Okay, so like I said, I could spend 2 days all the stuff we could do with this, but just something to go back and take a look at. Okay? Now, let me do this. In addition to the coding, next thing I want to look at real quick is geospatial. There's tons of geospatial information out there. If you're tied to an office that's got a geospatial department, they may have access to data. All right. Go ahead.
Yeah, before you run that, can you manually edit those lines, take that total and out, drastically?
Oh, sure. Yeah. No. The question: Can I come in here and start performing some manual edits on these? Absolutely. I could come in here and draw a line, just like this, just to do something. And if I select this segment here, there are options that I can go into. Where's my edit geometry? You'll see that I have options here for. I can fit a curve through it later. I can do stepped offsets. Anything I could do with grading before. Here's trim, so we can do trim and extend. We could trim that. Select my cutting edges or these guys. What am I going to trim? I want to trim out that guy right there. Okay. That's a great question. It does. So it'll if it removes a segment, it's going to, whatever piece I took out, it's going to maintain those. And all my stuff's at 0, so I can't show that to you right now, but if I had data, I could grab it. What I'm talking about with that for QA, QC, like my guys picked up driveway shots. If you pick up the driveway itself, we could come in and we can take a look at edit elevations and look at the elevation editor. If you look at the editor, we'll look at the panorama here, and for every shot, I mean, it puts a station, for lack of a better term, to where you are along this. As I pick points, you can't see it on the screen, but it's highlighting vertices, but it's telling me what my grade is at every one of those segments. So like I said, QA, QC, you could grab a section of sidewalk and start scrolling down 1%, 1.2%, and all of a sudden you see, 16%. Like what happened there, and you can go up and roll, see what the elevation is at that point, see what might be going on. Okay? Okay. So on the geospatial side, I want to bring in some data. Maybe I want to, the surveyors that I work with used to always tell me the GIS meant get it surveyed. All right, but the value, the data that I'm going to get from them is still very, very beneficial information. For example, if they have property lines, I'm not going to take that necessarily and use that as gospel, but I can use that to tell me where to go out and start looking for irons if I don't have an idea where they are right now to begin with. All right, so if property's already been, the GIS department has parcels already created, I want to leverage that in my drawing so I can maybe then start searching for irons or something like that. Let's see how we can do that. There is a tool within Civil 3D. It's our geospatial tools. It's based on map. I'm going to type the command in right now. The command is I don't know what the command is. Map delete space. Okay, we renamed it. Hold on. I'm going to get it from my button I made yesterday. Okay. It's the map task pane. All right, for those who were here in my CUI class. First use of my button. All right. My map task pane, I could have brought it up by changing my environment here, but my task pane from within map is going to give me access to my ability to bring in geospatial data. So I'm going to grab this. It's very simple. We'll just say data, I want to bring it in. We will connect to data. There are a number of different geospatial file formats that I can select. We'll wait a moment while that populates. I can connect to everything from ArcSDE, Oracle, SDF, Shape. All right, number of different file formats. There's even some really cool stuff for aerials, like a WMS file you can attach to aerial photographs on the internet, kind of like a USGS or a Google. Then as you zoom in, it will serve up aerial photography on the fly rather than carrying around a real large raster image. All right. So in our case, I just want shape. I've got, we'll give it a name. We're going to connect up to the parcel information from the GIS department. We'll go to the shape file, shape folder. I'm going to grab the GIS for my parcel data. We'll say open. It's all of the parcels for the county, and I don't want that because that's like 165,000 parcels. I could process it, but I only need a small area. So rather than just adding it to the map, I'm going to add it to the map with a query. And I'm just going to tell it I want to see data located on the map within this rectangle. So I'll back up and we'll just take and create a box to show it what area I'm looking for. Okay, that guy looks good. We'll say OK. Adds layers. We will come down and zoom back to this guy. Okay. There are my parcel data that's been added. Now I can't see through any of it anymore, so what I'm going to do is we're going to change my style. We'll just change one thing with it. We'll come into the color that's being displayed, and we will set that just screen back so that I can look through it and still see the aerial. So we'll display order, send that back to the back. All right. That's all I'm going to need for that right now. There is my parcel data. Now the cool thing about this is if I was going to send the guys out, maybe I didn't even know there was a separate parcel out here. All right, didn't show up on what I was looking for, so I can send my guys out maybe to find those irons, or I've got this bizarre shaped property here that I might want to give the guys some idea in the trees where to be looking for this particular point. Okay? First thing, if I select the object itself and right click, I can go to Show Data Table, and it will drill down into the shape information and it will start showing me data about that particular parcel. So we'll come down, I can see it's residential, it's owned by a guy by the name of John Unruh. I can see the road, I can see the city that it's in. All right, any information that's been associated with it, I have access to that data now. All right, so if parcel index numbers or things like that are recorded with your geospatial folks, we even had survey people that would take, if they've done surveys in a lot of different places, they would take legal descriptions and want that added into the database. So now I could do a query, I could touch the object, if the legal description or other data was available, I would have access to that immediately. All right. In this case, I'm not really worried about calling John on the phone. I just need his property information. So, excuse me, what I'm going to do, I'm going to highlight it. We're going to check it out. All right? I've checked that out of the shapefile. Because I've checked it out, now I can do other things with it. So, for example, we'll come into our database here under Figures. Throw my raster image back to the background. We're going to come into Figures here. We'll say Create Figure from Object. Select the parcel. We'll say this is whatever, lot 22, whatever it happens to be. And I'd like to associate survey points with all the vertices. We'll say OK. So the parcel is processed. If we look at it, it shows up in my list here. If I highlight it, we can come down and survey points. There will be points that are added to that at the end. For example, like point number 38, what do we get for descriptions for those guys? Oh, we'll do this one more time. And my Figures, lot 22. We will, well, let's take a look at this. We can do a inverse on it. Get some information about it while we're looking at it. I can see the acreage. I can see the length around the outside. Once again, if it's stuff that was recorded at survey grade, that may be helpful. If it's got elevation information, we can pull that as well. I want my survey data here. We're going to come down, modify figure, create survey points on figure. Do I wish to associate them with the vertices? Absolutely. Those have been associated. We'll come down in my list now for survey points, and we scroll down at the bottom, and now I have these additional ones that were tagged. They're in day 3 as far as they didn't have a description. We could add something later. But for right now, point number 41, I'll drag that in. It automatically goes and finds out where that particular point is. All right, so I could drag those into my drawing, and then I could send my field guys out with a data collector to locate where those are. All right, at least in the vicinity, especially ones that might be difficult to find like this. Yeah, the question was, can I set the numbering so where it starts and where it ends? Absolutely. If we come into my my point information, I can drop this down and we can start setting data about what point to start with and how it should increment, so we can control all of that. Okay? All right. Last thing I want to do on the geospatial side, I have data. I've dragged it across from geospatial. I'm now using it or leveraging it on the survey side. Now let's say I've collected some data or some of my line work that we've used here. I'd like to take this line work, somebody's asking me for it down at the municipality, they want to show it on their GIS and they're in a metric system. Rather than me going through and recomputing all of my stuff, I can transform it on the fly. So let's take a quick look at this. I'm going to open up a drawing here. This is in UTM Zone 16 North. So I've got a different aerial photograph. I've got parcels brought in. I've got soils information. They'd like to see my road lines, or they'd like to see the trees that I've captured. Let's take and split my screen in half here. So this is what we're currently working with in State Plane. As I move around, there's coordinates at the bottom. I'm like 1 million by 1.8 or 1.9 million. Come over on this side, I'm throwing coordinates around that are about 4 million by 400 and some thousand. All right, somewhere in that range. Let's do this. With this guy highlighted, my figures, the road that we collected, for example, if I highlight that, notice how the road is automatically being reprojected to UTM. All right, I need to give them a copy of that road. I need to do nothing more than highlight this, drag it into the drawing and drop it, and that geometry is automatically created in their file. All right, same as what it was in mine. That point that I did on the parcel here, point number 41. Let's do this just so we can see it happen here. I'm going to edit the point. We're going to change how it's displayed on the screen or how it's labeled. So I'm going to change the style here quickly. So we'll have label style. I'm going to change that to display northing and easting, one of my predefined ones. Okay, so there's the northing and easting of that point. And that is point number 41. So let's come over here in the UTM. That's going to be somewhere over in this area. So we'll go to survey points, point number 41. We'll drag that into here and let go. Points automatically displayed. Let's add a label to that so we can see what it is. All right, once again, you see it's in metric. We'll come across label style. I've got one in this drawing that is northing and easting as well. All right, same point, same database, but it's transformed it for us on the fly. All right, so I don't have to. Can you read that? Okay. All right, so I don't have to go through and recompute it. So if I have guys that go up and pick up trees, or I pick up manholes or something like that, and look, we'd really like to show the utilities that you collected in our geospatial, but we're in a different projection than you are. All right, I need only bring up a drawing, associate a different projection, drag it in. I can have it transformed for me directly on the fly. Can I drag it? That's a good question. Can I drag it from one drawing to the next? It won't transform it. And the reason it won't is because the drawing is one projection, it sees coordinates. The key here is the database. So both of these points are tied to the same database, so if this data changes, these would be updated. So I would need to take and drag it out of the database is what's controlling it. Yeah, if I were to do a copy and paste, it would maintain the same coordinates.
So if you had a drawing for municipalities, utilities, you want to break road line, whatever, you would have to do a survey figure line.
Well, if I had a municipal's drawing and they had utilities that were shown and I wanted them on my system, I would need only create a database. Once I have a database, I don't need to convert theirs into anything. I can just go to figures within my database, say create from drawing, select those objects. They'd now be defined in my database, and then I just drag them into my drawing and they be transformed. Also, having said that, we're built on top of math, so without even using the database, if it's just geometry that I'm changing, I could create another drawing with a different coordinate system, and I could do what's called a query. I want to query their drawing for all their pipes, all their structures, that stuff, and it would, bulk do all that on the fly. Wouldn't be in the database, but I could do it in one step then instead of making the database if I don't need it. Okay? All right. I got a couple more important things I want to show you here real quick. Extending the, I'm going to close my UTM drawing here. Extending my point functionality. Let's do this very quickly. I'm going to go ahead and erase and get rid of my points and my line work out of the drawing. We'll get rid of those parcels and use my cool new tool here to shut that guy off. Okay. All right. I want to pick up trees. All right. Point number, northing, easting, elevation, description. But then I got an arborist who's all over me that they want species, they want condition, they want the size, they want all this other stuff. All right. Really cool thing that we used to do. When you survey stuff, survey accuracy, that's why we have it surveyed, so that it's the highest level of accuracy possible. Trees. All right. If I'm not going to use the tree location as part of a my surface creation, I just want location. We would send guys out, because it was the arborist, they would know all of the Latin names for all these trees that they would want to calculate. We'd send them out with a handheld collector, all right, that's got sub-foot, now some cases even like sub-8 inches accuracy. We'd let them collect the trees themselves, all right? So they collected, we'd set the values so they couldn't alter their PDOP or anything outside of what we would consider acceptable. Let them collect the trees, they fill in all the attributes that they're looking for. Now, when they're done, they can export an ASCII file that is, their point number, if you will, and all the other data that they need. If I want to bring that into my drawing, I certainly can do that. I can extend my point database to now, handle more values than what I would have otherwise. The beauty of this is what we used to do for our customers is instead of, because what would typically happen, the arborist would go out there, they'd tag the trees. They'd charge the customer, or whatever, $10 a tree to go out and pick this stuff up. Then us as survey people would go out and visit the same trees for another $15 because we were more accurate than what they were. And then we would calculate and put in a tag value. So what happens, the customer's now got an Excel spreadsheet with a bunch of trees. They got our drawing with a bunch of trees and numbers, and then they're looking, okay, what is a 1215, trying to figure that out. All right, what we can do instead, we send them out with this collection device. Only one person visits the trees. He collects everything that he needs, and we're able to dump it into Civil and have all the data right there. So now if I'm going to clear a section of right away, how many trees am I unloading? Are they quality trees, size? The flexibility is incredible. So let's look at this very quickly. I want to extend my database. So we're going to go ahead and go into settings here. Points, I'm going to come down to user-defined property classifications. All right, I'm going to create a new one here. We'll say TR for tree species. And string, it's going to be text. That'll be fine. We'll say OK. And I'll create another new one here. We'll say TR DBH, which is diameter at breast height. I spent like 20 minutes with an arborist, and that was the one cool thing that I took away from that. We're going to say distance. I can say that it has to fall within a really low number and a really high number. That'll be fine. And I can put in a default value. We'll say 0 if it wasn't collected. We'll do one more. We'll say TR, and we'll say condition. And that's a string as well. All right, so I have these three values now that I'm going to extend my database. Let's take a look at this on the to import these now. Let's take a look at point file formats. Typically, if I'm bringing in files, I'm only bringing in point number, northing, easting, elevation, description, comma delimited. All right? I'm going to right-click on this guy. We're going to go to Properties. Actually, let's not modify that one. Let's create a new one. We'll copy one based on that, and this will be my trees. Here's my column for point number, northing, easting, elevation, description. I'm going to go to this guy, and here's my new values that I created, in addition to a whole god-awful amount of other ones we can use. Even starting to get into intensity for LiDAR data, and you start digging into it, there's an incredible amount of stuff we can do. So I'm going to say I'm going to bring in species. We'll bring in DBH, and we'll bring in condition. All right? Okay. So now, the arborist gives me the ASCII file that he took and created. All right? We're going to process that. Let's take a look at the ASCII file here very quickly. We come out. Here is park trees. That's all it is. All right, he's dropped point numbers. There's a coordinate. Elevations I don't really care about because I'm not going to use his elevations anyway. But then I've got a code that maybe he put in for a description. I could use that or not. And then species, size, and condition. So if I come back into Civil here, we're going to go ahead and say insert, points from file. I'm not going to use point number northern easting elevation. We're going to come down and use my new one for trees. Source file is going to be this guy, park trees. I'm going to add those to a special group called trees at this point. We'll say OK, and it processes it. We're going to change my display order, send that to the back. Here's all the trees that have been collected. Now when you look at it, it looks like trees that we've picked up. These are defaults, these are codes that Civil would have used. But if I hover over any of these tree objects, actually we'll go into my editor here, edit points. We come down and look at the list, and I don't see it. Let's come back and look at points here. Here we are. So if we look at my points that were brought in, I may have to save the drawing to get it to understand that they're actually there, but we'll take and scroll across, and we can see that all the entries now have, whether it was maple, whether it was 8-inch, fair, good, working its way across. All right. These don't have that labeled. I could create a label style that would include those labels if I wanted to show it. So I could have it read 12-inch oak tree in good condition as part of my labeling process. Go ahead. Yeah, the question is, based on the attribute values, can I change the size of the symbology? Absolutely, I can do that as part of the description keys that are created when this is constructed. We'll come down under description key sets for my Civil here, where we would code the tree. We can come in, format, we've got scale factor, what do you want to scale it by? In this case, it was the first parameter I put in, or any one of those other values, so that a 12-inch tree can statistically look larger than a 6-inch and smaller than a 24-inch. So yeah, there's an incredible amount of flexibility. Because they are objects, as the tree symbol gets larger, the label will move away from it. So it will know not to overwrite itself as it goes through. Last thing I want to show you here, just very quickly, where we would extend that to, because I mentioned that about the utilities. Here's a quick example of that. I had mentioned about the, that's fine. Those values that we use to extend the database, here is an example of that. I've extended the database on my points, such that the points themselves now maintain invert values. So I did the exact same thing we just looked at, except instead of making a tree DBH, I came over and created import or invert 1, 2, 3, and 4. So these are the values that I dropped when I got to the manholes. And then what I did is I created what's called an expression. I said take the rim, subtract invert elevation 3, and tell me what the actual invert is. Okay, so you have guys taking shoot structures. They don't normally do the inverts at the same time anyway, which is nice. They go back out later, they pick up the inverts, and they apply it. So the beauty of that is if you come back later and adjust the overall elevation, say 120, well, it was a bust or something in the field that needs to go to, 112 point, whatever. We'll throw something like that in. We'll click, and all my inverts and stuff update automatically. All right, because those things don't change if I go down 7 or I go down 3 or whatever. So I add that to it. It'll take that same process we use for trees. I can apply it to culverts or anything else that may change. Yes. Absolutely. Yeah, can the attribute values be added after the fact? Absolutely. Just like those trees, I could have shot them once and then came back later and extended the database, add more data to it. What would happen is, the question is, where would the survey people enter that data? Depending on their collection device, if they get exported as an ASCII file, the number that they shot originally, and then those attribute values would be ASCII. So if they do it in a collector and export it into Excel spreadsheet, ASCII file, text file, that's all we're looking for is rows in like common limited file formats is all it needs to be.
Once you have all your trees in, once you have all your trees in, we are supposed to attributes. Sometimes we want the ordinances where trees are considered, considered big trees, or a birch tree that's small, which is in good condition, or an oak tree that's.
Yeah, the really cool thing about Civil is because it's based on top of AutoCAD, it extends AutoCAD's functionality. There's a tool within AutoCAD that's called Quick Properties. If we come down to, we'll say Properties here. If we go to Properties, a lot of these trees may be in poor condition. I live there, so I know. We'll come down and I'm going to grab, or I'd like to find, oops, Quick Properties. I want to search the entire drawing for Kogo points, whose tree condition equals poor. And we'll say OK. And it fans out and finds the trees that are in poor condition. Now, can I extend that further? Yeah, I can go into that tool because there was an include in the selection or exclude. I could say I'd like to include all the birch trees, so it grabs all the birch. Then I could say exclude anything that's not poor. All right, so I'm doing it this way. There's other ways we could dump it and use the query tool for math, but in this case, I'm doing it right off the Civil points. So I can start to do some right here. Is there one more question? And then
Did you change the symbology based on the
good question. Can I change the symbology based on the attribute data? Yes, but I'd have to look at that. There is, I may need to leverage math to do some of that. When the description code is going to come in, there's only going to be one style that's associated with it. But using point groups, I could do it through point groups. I could apply a style to the group. I'd have to play with it a little bit, but I could absolutely do that. Okay? All right. Like I said, before Tom smacked me, I was supposed to have you out of here 10 minutes ago, so before he rushes the room. We are at 10 after. Thank you very much for coming out early.